going to start recording, and I want to share my screen with you all. Ms. Kelsey, just let me know when you're ready. All right, so. All right, so this was our bucket list question. If you have anything on it. And the whole point is dream big, plan your work and work your plan. You know, everybody has something that they want to do, and you may not call it an item on your bucket list, okay? But there are things that you want to accomplish. Some are personal, some are professional, and some are just, you just want the experience, you know? But again, dream big, plan your work and work your plan. So if it's on your list, you know, figure out how can you do some of those things on your list. Okay, sometimes you might be able to do them by yourself. Sometimes you might need other people. And that's okay too, because no man is an island. You know, some things you just can't get there by yourself. Somebody might open the door and then you carry on, you know, but no man is an island. So remember that. Nobody got where they got on their own. Somebody helped them. All right, so we're going to talk about tables of relative frequency. Okay, so we're going to start with the notice and wonder. And again, this notice and wonder is in Summit, but unfortunately, you may not have, you probably cannot see it. So I am going to show it to you, darlings. So now we are, bam. So now, notice and wonders serve as our warm-up. So in notice and wonder, it is about observation. So, given this situation, this two-way table summarizes data from a survey of 200 people who reported their home environment as urban or rural and their pet preference, a dog or a cat. So you see the table, excuse me, what do you notice? So looking at this table, what do you notice? Tell me some characteristics of the table. And again, you can type in the chat. What do you notice? Nobody? You don't see anything? All right. Again, the teacher's gonna help you out just a tad. All right, so I see that the horizontal total as well as the vertical total is 200. So I noticed that the total, whether I'm looking at the column or the row, is 200, and it matches the number of people who participated in the survey. Oh, I don't know why I'm yawning this morning. So, anybody see anything else about the table? Because part of this is about interpreting data from a table. No notice, no wonder. All right, so if you don't notice anything, what do you wonder? What questions do you have as it relates to the data being presented in the table?
I'm surprised, Ms. Hicks, that so many more urban households prefer dogs.
Yes. So if we look down this column for urban households, we see that 54 of the urban households had cats, but 80 of the urban households had dogs. Now remember, urban. Urban means they live where versus rural. Anybody? I wondered why. That was my wonder. Why are there more dogs in urban areas than cats?
Yeah, I wondered that too.
Yeah, like, okay. Anybody? All right, ladies and gentlemen, I think I had this conversation with you all before. In order for this to work, you all have to talk. You have to talk, chat, or something, because again, your silence means that you understand. And if you understand, that means that I won't have to spend as much time on it, and we will move on. So again, this is about, this table displays that data, and then as we move on, questions will be drawn about the data as it's presented in a table.
Okay. That's great, Keon.
What do you?
He said rural is the countryside, urban is the city, right?
Yes. Yep. So again, so urban, that's like us. We live in Philly. Philly is urban. But rural, maybe you live out in Lancaster near the Amish. Oh, or maybe you live out in some parts of like Montgomery County, Delaware County, where you have more space. Absolutely. So again, what we see is in the city, more people have dogs than cats. And again, that was a wonder for both Miss Kelsey and I. Like, why do they have more dogs in the city versus cats when you think about space?
Because I would think, being a dog owner myself, that you would want all of that land for your dog to run around.
Right. Exactly. That's what I would think too. And being in the city, a cat is low maintenance. Because I don't have to walk my cat. My cat walks herself. She's very clean. Versus, a dog, you have to take the dog outside of the house so that they can do their business, or at least provide a yard. Mm-hmm. And they need like a little more activity than cats. You got to walk them, you run them, you throw, you do those activities. My cat, please. It's the little thing that I dangle on the string, and she fights. All right, anybody notice or wonder anything else? Okay, well, we shall see. All right, so I'm gonna stop this share for a quick second because Miss Kelsey, you ready for the breakout room?
Yep.
Okay, so in the breakout room, Sean only has to do reading. Daquan, Liv. Did we lose Liv?
Looks like it.
Lost Liv and Aaron. I don't know what happened there. All right, so Sean has reading. Daquan has the entire test. Zaire has the entire test, and so does Amir. So they'll probably, Amir and them, they'll probably be with you for a while. Amir and Zaire, I am going to send a text to the teachers to tell them that you, Daquan, Zaire, and Amir. Well, Amir, I have you next. So you take the test. When you finish, you come back to me. But Zaire and Daquan, I'm going to send a note to the teachers to tell them that you are testing with Miss Kelsey, and when you finish your STAR testing, you will go to class.
Should they start with one in particular, or it doesn't matter? They just do both?
No, doesn't matter.
Okay.
Doesn't matter. Now, Kelsey, you want me to just send them to the breakout room?
Yeah. Yeah, you can just send us the room together and yeah.
Okay.
Yeah.
All right. I'm going to do it manually. Create the room. Miss Kelsey, Daquan, Amir, Zaire, and Sean. All right. Daquan, Amir, Zaire, and Sean, you should have gotten an invitation, and Miss Kelsey should have gotten an invitation to join the breakout room. Miss Kelsey is there. Zai's there. Mir, thank you. Mir's there. Sean, you and Daquan, go to the breakout room. You should have gotten a message. Sean, you better not went back to sleep. Come on, gentlemen. Daquan and Sean, join the breakout room. I can't force him in there, can I? No. I can't put him in there. Daquan and Sean, join the breakout room. They are waiting for you. All right, so Shanice and Keon, it's probably just going to be us for the remainder of the class. I don't know what they're doing. I'll go back to them in a minute. All right, so when we talk about, again, in this notice and wonder, what I wanted you all to get was that when we go across the row, this means that there are 54 families in the urban area that have cats. Here, 80 urban families or urban households have dogs. Here, 42 rural families or rural households have cats. 24 rural households have dogs. So the total number of cat households are 90, a number of cats in households, urban and rural, is 96. For dogs, 104. When we add 96 and 104, we get 200. Now, there were 134 households that were urban, or 134 pets in urban households, 66 pets in rural households. And again, 134 plus 66 gave 200. So again, you can see that regardless of whether you add the rows or the columns, you will still get the 200, which is our participant. So now, so that was the notice and wonder piece. So now we are moving to the next way to organize data so that we can talk about probability. So we've already been doing a list. And again, a list of flipping two coins. You can either get heads, both heads. The first one can fall heads, the second one can fall tails. Or the first one can fall tails, the second one fall heads, or they both fall tails. Okay? So now we look at organizing probabilities in tables. So they're giving us the information. So now we are going, to be using a two-way table, like we saw in the notice and wonder, to record our events. One event goes horizontal across the top, and the other event goes vertically. It goes down the side. So looking at this, and we are going to do this together. Oh, let me go back. Close this out. Oh, come on. Okay. All right, so I am going to take all of the information out of the table. All right, and I'm gonna take these out too. I'm gonna take out the questions. So on your paper that you should have, I want you to recreate this table. So I want you to create a table that is a 6x3. So rolling the die is the first event. And the second event is flipping the coin. So here, heads and tails. So we see that event 2 is your horizontal, and rolling of the die is your vertical. So now, once you get your chart down, we are going to plot or graph this information in the table. So I'm gonna give you a chance to get it, get down the table. What happened there? All right, that line is cool. Let me see. Yes, I can. I'm gonna see if I can do it on my phone because I don't want to share. Excuse me for a second. All right, Shanice and Keon, y'all ready? What you got? There's some on here. Y'all ready? All right, well, I'm gonna take your silence as a yes. So I'm gonna share again. So now, this is what we have. So we did this experiment 10 times, and these are the results. So the first time we did it, we got 3 and heads. So that you will put an X in that block. Oh, goodness. Wait a minute. Let me blow that up a little bit. Hello. All right, so we put an X in that box for the first trial. For the second trial, we got 4 and tails. So we put a mark in that box. What happened? Okay. So we grabbed 3 heads. We grabbed 4 tails. The third trial, we got 3 and tails. So the mark should go there. What is going on? The fourth trial, we got a 5 and heads. The X goes there. Now, for trial number 5, we got 3 and heads again. So we mark the first one with the X, but anything after that, we use a number, and that number will tell us how many additional times did this combination occur. So we have the initial one from trial 1, but this one here represents trial number 5. So here, that shows that we had 2 occurrences so far of 3 and heads, of the pairing of 3 and heads. Does that make sense? Okay. So now, trial 6. You got 2 and tails. Trial 7. You got 1 and heads. Trial 8. You got 2 and heads. Trial 9. You got 3 and tails. And again, We've already had that occurrence in trial 3. So this is an additional 1. And then lastly, we got 6 and heads. So there were 10 trials, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have all the data represented in the chart. So now, that's what your paper should look like if we are taking these results and putting them in a table. And again, remember, the 1 here means that it happens and then it happens again. The same thing here. It happens, then it happens again. So if your table doesn't look like that, then I would suggest that you change your table so that it does look like that. Because the next slide is going to expound on it. Okay, we good with how the data went from the results to the table? Okay. So now, we can now ask some questions about this table. So, what percentage of the results has a 3? So again, we are only looking or concerned about what is happening on this row. Anybody have a question? Or I'm sorry, anybody have a response? What you have?
I said 25%.
25%. I don't know. Let's see. How you get 25%? How many? Go ahead.
Each X counts as one side of a coin, right? Like one trial, right?
No, look here. They want to know how often did we get a 3?
Yeah, so I counted every X as one trial. So out of 1, 2, 3, 4, 5, 6, 7, 8, there's eight trials on the table. So there's only 2 in the number 3 column. So
Is
I
it
did
8?
2 divided by 8.
What happened to the ones? You got to count them too. There are
Oh, I gotta
8
count the ones.
X's. Yes, because
So
that. All right. So what's your
hold on.
what? Yeah, yeah. I'm there. I'm texting to the teachers about the students we're testing. All
So
right.
it'd be 40%, right?
Yes. So now there are 4. 1, 2, 3, 4 out of the 10 trials that we did. Yes. And it would be 40%. Remember, percents and decimals and fractions all related. So if you couldn't figure out that it was 40%, you would have done 4 divided by 10, and you would have gotten 0.40, which is 40%. Okay, so now we had to use a row for that information. So the next question asks, what percentage of the results has an H? So now we are looking down the column that says, that has the H header. How often did that occur?
6 times.
1, 2, 3, 4, 5. Yes.
So it'll be
6.
60%.
Yep. 1, 2, 3, 4, 5, 6. So 6 of the 10. Yes. Currently, I have. Shanice, how's this going for you? You with me?
No.
All right. So, take a step. All right. So, these are the results of the trials. So, all we did was the first trial was 3H. So, 3 here, H there. We put the mark. So, these 4 tails, here's the row 4 and the column T tails. So that's this mark. Then 3 tails, that's here. So we just transferred the data from the listing to a table. And again, this means we rolled 3 and the coin and we flipped heads. We rolled 4 and flipped tails. I had to think about what it was. Roll 3, flip tails. So where those things meet, just like plotting a point, we went down to 3 over to H, made a mark. We came down to 4 over to T, made a mark. Came down to 3, went over to tails, made a mark. Went down to 5, over to heads, made a mark. Now, because both trial 5 and trial 1 came out the same way, the first time we mark it with an X. Any additional occurrences, we start adding numbers. So it happened, and then it happened one additional time. So altogether, 3 and heads happened twice. Make sense? Wait a minute, you all. I had to come out of here for a second. Give me 1 minute. All right, so Shanice, did it make sense? A little better now of where it came from?
Yeah.
Okay. So now, because we're going to be looking at frequency tables for a couple of, for at least the next 2 days. Okay, so again, so we just recorded, we went from the trials to the table. So here were the results of the trials in a list. We just added them to the table. So we had gotten to 5. Again, 3H, that was the second occurrence. Then we had, for 6, we had a 2 and tails. Go down to row 2, over to the column for tails. Trial 7, down to column 1, to row 1, over to the column for H. Okay, so you see how that went now? It makes more sense? Yes, no, maybe. So Shanice, we just were asking a question, asking questions according to the data. So now it asks what percentage of the results has a 3? Well, you know, if we can figure out the probability, which looks like a fraction, we can then convert it to its percent. So it says what percent of the results has a 3? So we are looking at the third row. We have 1, 2, 3, 4. So we would have 4 out of the 10 trials that we did. But again, 4 divided by 10, you would have gotten 0.40, or you would have gotten 0.4. But we know that 0.4 means 40%. Okay, because they'll drop the back 0. So that's how he got 40%. And then the second question asks, what percentage of the results has an H? So now we are just looking in this column. And we see 1, 2, 3, 4, 5, 6. So 6 out of 10 gave us 60%. Make a little more sense now? All right, you good? Okay. Now, the next thing we need to...
Are you doing labs today?
Say it again?
Are you doing labs today?
Yes. Yes, we are doing labs. Now, we are coming up on our time. So today at 11:30, you all should have gotten that we are community meeting at 11:30, and tonight 5:30 to 6:30 we are having a virtual open house. So please tell your parents. We would like them to come and, you know, stop by and check us out. Hey, Mr. Gabriel, what's up? How you doing? Let me check you.
I'm good.
Let me see, Mr. Gabriel, you finished your testing?
What testing?
Did you take the STAR? You did STAR testing already?
Yeah.
You did both of the parts?
I don't know.
Oh, wait, man. I'm looking right now. Let me see. Yes, you did. You did them both. So you good.
Okay.
Okay, bet. All right, so I'm having lab this afternoon. So if you know, you'll get the email. So you are always welcome to stop by. Mr. Harper, I'm gonna look at your stuff and I'm gonna send you a response via through Hangouts. Okay. So that is that, ladies and gentlemen. I will, let me see. Yeah, okay. So you all have a good one.